Good evening to one and all. We, Project 32, mentored by Ravisha Sharma, present to you all our project MediBlock. Being a thyroid patient myself, which requires regular tests, I understand the challenges of managing historical medical records, which is also cumbersome to carry to the hospital every now and then. So, taking inspiration from the same, today we address a pressing problem within India's three-tier healthcare system, which is first, it being highly centralized and unorganized. Secondly, mostly relied on paper-based documentation. And lastly, having a high risk of patient privacy violation. Hence, our proposed solution for the same is a blockchain-powered decentralized platform for secure medical record management, along with EHR storage with fine-grained user access controls.
Now coming over to the tech stack, we have used Ethereum, which is a decentralized blockchain platform to establish peer-to-peer network that securely verifies and executes the smart contracts. Next is Ganache, which is a local Ethereum a personal blockchain. MetaMask is basically a browser-based Ethereum wallet. The front-end design of our website has been created using HTML, CSS, and JavaScript using Bootstrap. The server and backend of our website are controlled by IPFS server and Solidity programming language. Workflow. So this particular figure here demonstrates the workflow of MediBlock, which is powered by IPFS, where patients' medical record are stored on the distributed file system, not on any centralized entity. A patient or a doctor can either log in or register by first connecting with MetaMask and accessing the private key from the Ethereum wallet. A patient or a doctor can access the patient's record by interacting with a smart contract on the Ethereum blockchain. The client can then upload a record file to the IPFS, whose address is linked to a patient block in the Ethereum chain. The client can get all the record addresses stored in a patient block from smart contract and get all the record file by its address from the IPFS.
Moving on to the demo of our project. To begin with, this is the home screen of our project MediBlock. We have used the MetaMask Chrome extension, which connects the Ganache server to our website as soon as the home screen is loaded. So first we'll log in or we'll register as a doctor. So herein the doctor needs to enter the details such as name and age. Once the doctor clicks on the register button, a transaction is generated, and that transaction needs to be confirmed, following which the doctor will be registered into our server. So herein the doctor is registered, and we have the doctor's portal wherein they can see their personal information. Now let us register as a patient. We will switch the Ganache server account to that of a patient. The patient needs to register by entering in their details. Once again, the transaction is generated and it needs to be confirmed. Once the patient is registered, here we have the patient's portal where they can see their personal information. They can also view their medical record, which is right now empty since it is a newly registered patient. We have given complete authority of the medical records to the patients, so they can very easily grant or revoke access of their medical records to any of the doctors available on our server. So here we can see that the medical record access has been given to a doctor. Now let us log in to the doctor to whom we just provided access of the medical records. So logging in as the doctor. Here we can see the medical record. The doctor can enter in the diagnosis and the prescription or any other necessary details regarding the case. They can submit their diagnosis. Once again, once the transaction is confirmed, You can see that the diagnosis has been submitted. Now let us log in as the patient to view the medical record that we just submitted. So on the patient's portal, we can see the medical record and we can view that the medical record we just submitted via the doctor's portal is visible here. So our website allows easy, secure, and decentralized storage of medical records. Now let me run you through our GitHub repo. Herein, under the contracts folder, we have the smart contracts that we built. For the migrations folder, we have the different migrations files, which are basically default files which are created when we run a blockchain product in JS. Under the SRC folder, we have all the front-end files, and the truffleconfig.js is a default file which is created whenever we run a blockchain project. Here we have the Ganache server or the blockchain server that we are using, wherein we have a lot of dummy accounts. The address here is the public key, which helps us to recognize different users. And we are using it to register the different doctors and patients into our server. The balance is a dummy Ethereum balance that can be used to carry out different transactions, as you can see here. And here are the contracts that we are using. For file sharing and distribution and storage, we have this IPFS server. We are using the IPFS server. And as you can see here, there is the record of the patient based on what we just saw in the demo.
As recommended to us by our mentors, that we should add some of the pages so that the patient can know better about the hospital and the doctor he wants to approach to. Hence, we thought of adding some pages which are based on the information related to the hospital and the doctor. So this is the button which would lead us to the home page of hospital. This is the home page. Then we have the about section here, also with the testimonial from the patients, a testimonial video from the patient and the doctors. Moving ahead, we also talk about the services that hospital provide. Next, we have the doctor section where we have provided about the information and the social links of the doctors along with their ratings based on the feedback of their current and past patients, so that the user can decide better which is the better doctor for his or her treatment. This is the contact section where we have provided the Google Map also with the section to contact to the hospital in case of any queries. This is the footer, and these are the changes that we made up to our website as recommended by our mentors to focus more on the front end and to alleviate our website basis on our front end. That's all for the demo. Thank you. Moving ahead.
Coming to the challenges, firstly, understanding the flow of medical record proved to be a significant challenge during the development of this prototype. We spent a considerable amount of time figuring out when and whom to give the access and when to revoke the same. Secondly, even after learning Solidity, writing smart contract was a bit of a task. We started by developing the demo contracts, decided upon the workflow and access rules, and then started with the contract thing. Lastly, initially we aimed at implementing the cross-hospital sharing platform. But because of the time constraints and we being very new to the technology, we decided to build a strong foundation for a single hospital first. And later we have decided that to implement this feature in the future once we gain more expertise. Learnings. Throughout the process, we have gained invaluable insights and learning. Firstly, learning and working with Solidity, which was very new to us, empowered us to build smart contracts and develop a user-friendly front end. Secondly, developing MediBlock using blockchain technology taught us how blockchain ensures data integrity, immutability, and transparency. We have also learned about the importance of the electronic health record EHR and the need of strong security measures to protect patients' data. Lastly, choosing a very unfamiliar tech stack like Solidity taught us to get out of our comfort zones and to start developing small components of the project along with learning and researching side by side.
This project carries a lot of future scope. Hence, we aim to leverage it more by addition of AI/ML powered chatbot integration to answer facts of the patients, having it as a mobile app too for user convenience, facilitating the upload of historical medical records as well, and last but not the least, enabling cross-hospital data sharing as well, which was also mentioned by Bhumika.
The project's completion brings forth numerous advantages, the key benefits being elimination of the need to carry bulky medical reports. The implementation of an immutable system guarantees data integrity. Patients gain control over their health data, empowering them to make informed decisions. Embracing blockchain technology leads to substantial cost savings, estimated at $100 to $150 billion annually. Moving to the conclusions, the first thing being the secure and transparent data storage solution based on blockchain technology. It safeguards medical information and establishes trust. Impactful future expansions such as enabling cross-hospital data sharing. The project also catalyzes a profound transformation, overhauling India's healthcare system. And the timeline of the project is like, during the first week, we have spent time on identifying the problem statement to work on and finalize the project. In the consecutive week, we spent time on choosing the tech stacks. From weeks 3 to 7, initially we have spent time in learning the tech stacks, and then we have started with completing the front-end part, followed by back-end. In the following week, we worked on integrating the front-end and back-end parts together. And the last week, we have spent time on preparing a comprehensive presentation.
So these are the resources that helped us in building our blockchain project. Thank you, everyone. This is Project 32 signing off. Any questions and feedbacks are deeply appreciated.